So, in the world of programming, how do you build, say, 1,000 different things without having to write 1,000 different pieces of code? Well, today, we're cracking open the master blueprint that powers pretty much everything from the apps on your phone to the characters in your favorite games.
Let's just dive right in with a classic example. Imagine you're a game developer, right? And you need an entire army of orcs. Now, one arc is short and fast, another one's tall and strong, and maybe a third has a special glowing axe. How in the world do you manage all that variety without literally writing separate code for every single orc? It sounds like a total nightmare. Well, the secret isn't to just buckle down and write thousands of repetitive lines of code. No way. The solution is actually way more elegant, way more efficient. It's all about working smarter, not harder. And it all boils down to one single core concept in programming. And that concept is the class. Honestly, the simplest way to think about a class is as a master blueprint. It's not the car itself, it's the detailed plan for how to build the car over and over again. This idea is so fundamental, it's the foundation of a whole way of thinking called object-oriented programming. So here's our game plan. We'll start with the basic blueprint, then we'll add some standard and custom specs, give it some actions, check out the automated assembly line, and finally, we'll see why any of this really matters in the first place.
All right, first up, the programming blueprint. And to make this feel real, we're not going to talk in abstracts. We're going to build something we all know, a car class.
In actual code, this is all it takes to get started. Just this one line, class car, creates our entire master plan. You see that colon at the end? That's super important. It's basically telling the program, okay, get ready, the details of my blueprint are coming right up. Right now, it's totally empty, but this is the foundation for everything we're about to add.
Okay, so an empty plan isn't super useful, is it? Let's start adding some details. And that brings us to the specifications, or what programmers like to call attributes for our car blueprint.
Now this is a really key idea. There are two types of specs we can define. Over on the left, we've got class attributes. You should think of these as factory standard features. Every single car that rolls off our assembly line will have 4 wheels. That's a rule. It's non-negotiable. But on the right, we have instance attributes. These are the custom options. This is stuff like the pink color. Each car we build can have its own unique color. One can be red, the next blue, the next black.
So our car has specs, which is great, but it's just a static list of features. It's kind of just sitting there. It can't do anything yet. So let's give it some actions. In the world of classes, these actions are called methods.
So what can a car actually do? Well, it can start its engine, it can accelerate, it can honk its horn. You know, car stuff. Each of these actions will be defined right inside our car blueprint as a method, which means every single car we create will have these abilities built right in.
But wait a minute, this brings up a really important question. If we create a red car and a blue car using the exact same blueprint, how does the red car know its color is red and not blue? How does it access its own unique information and not get confused with the other cars? The answer, believe it or not, is one simple but incredibly powerful keyword, self. It's how an object, like our specific red car, refers to itself. Just think of it as the car's way of saying me or my own.
And this is what it looks like in action. When you see a piece of code like def get color self, you can just translate that in your head. It's the car's programming literally asking, hey, what is my own color? See how self is the very first thing inside the parentheses? That's the special key. It gives each individual car a direct line to its own unique attributes, like its specific paint job.
All right, we've got a blueprint with specs and actions. But how does a car actually get built when we place an order? Well, that's where the automated assembly line comes in. In the Python world, this is known as the __init method.
The init method is kind of magical. Those double underscores, programmers often call them dunder, they tell you this is a special built-in process. You can think of it as the lead engineer on the factory floor. The moment you say, I want a new car, init automatically kicks into gear. It's the constructor that takes your blueprint and all your custom options and actually builds the finished product.
Let's just walk through it real quick. Step 1, you place an order with a single line of code. Step 2, the init assembly line immediately automatically starts running. Step 3, it takes those custom specs you ordered, like the color red, and assigns them to this specific car. And boom, just like that, step 4, your brand new, unique car is built and ready to go.
So why? Why go through all this trouble with blueprints and factories and assembly lines?
Let's try it all together and see why this one concept is so incredibly important and connect our car factory back to the real world of programming.
Let's go all the way back to our original problem. A game needs 100 different enemies. They're all orcs, so they share some common traits, but each one has its own unique health or speed or armor. This is the exact scenario where the class just completely shines.
By creating a single enemy blueprint, a single class, developers get these incredible superpowers. You need to make every single enemy in the game 10% faster? No problem. You just change one line in the blueprint, not in 100 different places. The code becomes so much cleaner, more organized, and way more manageable. And this doesn't just save a ton of time. It makes the code more reliable and a whole lot more efficient.
And really, that's the whole takeaway. Using classes is the difference between trying to build every single car by hand in a messy garage versus operating a clean, streamlined factory that can pump out thousands of unique cars, all from a single perfect blueprint.
So now you understand the core idea behind one of programming's most powerful tools. You have the blueprint. The only question left is, what are you going to build?